Today we are going to discuss the topics is types of sets. So, what are the learning outcomes today we are going to learn? Students are able to understand the concepts of null set, give reasons for whether the given set is a null set or not, understand the concept of universal set and subset, give reasons whether the given set is a subset to a particular set or not, explain the concept of finite and infinite sets, explain the cardinality of a set, solves the problems on subset and universal set, uses appropriate symbols for null set, subset, universal set, represent the subset and universal sets through Venn diagram, explain the concept of equal sets. So, let us discuss the today's topics. We are going to discuss here null set or a empty set, subset and universal set, finite set and infinite sets, equal sets, cardinality of a set. Let us recall what is a set. Yes, you might have learned in previous class, that is a set is a well defined collection of distinct objects. The objects in a set are called elements. Some examples: the set of natural numbers, n is equal set of 1, 2, 3 and so on. Here 1, 2, 3 are called as elements of natural numbers. So, 1 belongs to n. Suppose minus 2 is there, whether it is belong or does not belongs. Let us see, minus 2 does not belongs to n. You see second set, the set of vowels in English alphabet, V is equal set of A, E, I, O, U. Children, let us think. So, in previous sets you have elements. Now, is there any scope or is there whether there could be a set with no element in it? Is it possible? Let us think. Now, let us observe some examples. Can you find the elements of the following sets? Set A is equal to x such that x is a natural number less than 1. Please read, observe carefully. Once again I am reading. A is a set, A is equal to x such that x is a natural number less than 1. Set B is equal to x such that x is an odd number divisible by 2. Set C is equal to x such that x is an integer between 2 and 3. Read them carefully. Then let us observe. If you take set A is equal to x such that x is a natural number less than 1, you know actually set of natural numbers n is equal to 1, 2, 3 and so on. There is no such element less than 1 in natural numbers. So, there are no natural numbers that are less than 1. Similarly, B is equal to x such that x is an odd number divisible by 2. Do you know what are the odd numbers? Can you please? Yes, 1, 3, 5, 7 and so on. Now, there are no odd numbers that have remainder 0 when divided by 2. Okay? Now, let us observe one more. Let us observe C is equal, C is a set, C is equal x such that x is an integer between 2 and 3. You know integers are denoted by z, either positive, negative and 0. You see, in between 2 and 3, there you can see in between 2 and 3, is there any other integer? No, there is no integer between 2 and 3. Here you observe about 3 sets. What do you observe? Evidently these sets are empty, that means no element in it. Okay. Now, these kind of sets are called as empty sets. Okay. What is an empty set or null set? It can be called as null set also. Empty set or null set. A null set is a set with no element. A null set is sometimes denoted as empty set or void set. Okay. The null set is denoted by phi, a letter from Scandinavian alphabet. It can be denoted as empty flower brackets. Therefore, phi is equal flower brackets, empty flower brackets. It is very important, do not be confused. Next, you see very important note. The first here you see phi is not equal to set of phi. Here the first phi is a set, it is a set of 0 elements, that phi is a set with no element. The second set here you see, the second set means this one is a set of one element, that one element being the empty set. Understand? Again you see here empty set not equal to a set of an empty set. It is easier to see that they are not equal that way. So, do remember and be careful while reading this. So, after listening this in your textbook, do these problems, set of integers which lie between 2 and 3 we have gone through now, set of natural number that are smaller than 1, no, there is no such element. Okay. Let us think, you do these problems. Okay. Yes, set of odd numbers that leave remainder 0 when divided by 2, that we discussed. Let us consider a context. U is equal all the students of ZPHS Thadikonda in 2021 academic year. So, that is the definition of a set, that a set was defined like that. A is equal to all the students of 10th class of ZPHS Thadikonda in 2021 academic year. Now, let us see. So, now we are going to discuss a concept, universal set. Let us represent these sets by Venn diagram. It is a Venn diagram, one rectangular shape, and is represented by rectangle, a 10th class set, students set represented by A. Here consider set of all the students in the school as universal set. Now, what is a universal set? U is the universal set, that set of all elements or the universe from which given any set is drawn. The universal set generally denoted by mu and sometimes by u. The universal set is usually represented by rectangular shape to show in the form of figure of a figure. While we represent through Venn diagrams, generally the universal set is being denoted by rectangle shape. Now, see one more example for universal set. For example, for the set of vowels of the alphabet in English, U would be all the letters of the alphabet. Now, U is equal set of A, B, C up to Z, and A is a set that is which contains vowels A, E, I, O, U. Let us see how do we represent the universal set. So, now the rectangular shape one is denoted by U or mu, that is full alphabets. Now, in that there is a set A which contains the elements A, E, I, O, U. The remaining sets are outside of the A, but they both are there in the U only. Okay. So, this is the way to donate this is the way to represent this universal set in such a way. Understand? So, you could think in your own way, you can represent, you can give many examples for the universal sets. For example, if you take your family as a universal set, your whole family as a universal set, then you can relate the different subsets. If you take your school as a universal set, then how many classes are there? For example, if it is high school, 6th class, 7th class, 8th class, 9th class, 10th class. So, that these your school will be the universal set, and for every set it will be the universal set. From your school you can draw many sets like this. Similarly, you can come across many examples through your daily life situations. Now, let us see. We often use the number sets. N is a set of 1, 2, 3 and so on is the set of natural number. W is equal to 0, 1, 2, 3 and so on is the set of whole numbers. Z is the set of integers. Q is a set of rational numbers. Q is equal P by Q, where P belongs to Z and Q belongs to Z and Q not equal to 0. R is the set of real numbers. Real number contains rational and irrational numbers. Let us consider another context. N is a set of natural numbers 1, 2, 3 and so on. The question is how the set of even numbers can be formed, how the set of odd numbers can be from natural numbers. You can see even numbers are which are divided by 2, 4, 6 and so on, odd numbers 1, 3, 5. Here the natural number set is a universal set of even numbers and odd numbers. Children, here you can draw many sets from the natural number sets. You can draw the set of multiples of 6, multiples of 5, like that you can draw many sets from the natural number set. Okay? Now, let us see the set of vowels in English. V is equal, I have defined like that, A, E, I, O, U. The set of English alphabet, A is equal A, B, C and so on, Z. Here you see A belongs to V and A belongs to A. Element A belongs to V, set V, and element A belongs to set A. You see here, I am comparing both the set. Here element E belongs to V, set V, and element E belongs to set A. Element I belongs to set V, element I belongs to set A. You see, whatever the element there in V, that is there in A. Am I correct? Yes. You see, what do you observe here? Yeah. Every element in set V is in set A. Okay? You see, there is A, there is A. So, that all the elements which are there in A, V, that are in A. Every element in set V is in the set A. Now, we are going to discuss the concept subset. Let us see what is a subset. Now, we say that V is a subset of A and we denote it V is subset of A, and we read as V is the subset of A, or V is contained in A, or it is also read as V included in A. Denote the subset. You see, a set A is a subset of B if and if only if every element of A is also an element of B. The subset is that is denoted by A is subset of B. the symbol here A is subset of B. Now, think for a while and discuss among your friends. Consider set A is equal 1, 2, 3. How many sets can you form by taking as many elements as you wish from set A? Okay. Are you ready? Now, you see, you can write like this. Let set A is equal 1, 2, 3. Set formed by using the elements of A, can we write like this? Can contain 1 as an element. So, set of 1, set of 2, set of 3 like this. These are all called, if a set contains 1 element, that is called singleton element. Okay? Singleton set. A set contains 1 element, that is called singleton set. Now, again I can take 1, 2 as a elements, set of 1, 2, set of 1, 3, set of 2, 3. Again 1, 2, 3. What do you observe here? Set, let A is a set 1, 2, 3 and again 1, 2, 3 is a set. Every set is a subset itself. Understand? Now, yes. You observe here a set 1 is subset of A, set of 2 subset of A, same subset of 3 sets is a subset of A. Similarly, set of 1, 2 set of subset of A, set of 1, 3 subset of A, set of 2, 3 subset of A and set of 1, 2, 3 subset of A. Understand? Now, what here understand here, for every set we can write as many as the sets and you can think over how many sets we can write, and similarly every set is a subset, and the same way null set is a subset of every set, null set is a subset of every set. Do remember, this is the example for subset. Now, you can generate many subsets. If you take any set, you write on your own way. So, for example, if you are friends, Ramu, Somu, Sita, Lata, Rahim, Lakshmi and Zarina. This is a set A. Then you can write a different kind of subsets for the set like that. So, you discuss with your friends and write what is a subset. Okay? Let us consider a set of natural numbers n is equal 1, 2, 3, 4 and so on. W is equal is a set of whole numbers 0, 1, 2, 3, 4 and so on. Then here you observe carefully what are the elements are in the natural numbers are there in whole numbers. 1 is there, here 1 is there, 2 is there, 2 is there, 3 is there, 3 is there. Every element n is in set of whole numbers. So, that what do you say about natural numbers? Set is a subset of whole numbers. Understand? How we denote it? N is subset of W, that means natural numbers set is a subset of whole numbers. Similarly, let us observe the number sets. You can derive the relation among the number sets. N is a set of 1, 2, 3, you see here, and whole numbers 0 start from 0, 1, 2, 3 and Z here negative numbers 0 and positive numbers. Rational numbers x is equal p by q, where p and q belongs to z and q not equal to 0. R is the set of real numbers which contains rational and irrational numbers. Now, n is a subset of whole numbers. Whole numbers are the subset of integers. Integers are subsets of rational numbers and rational numbers are subsets of real numbers. So, the relation is N is subset of W, W is subset of Z, and Z is subset of Q, and Q is subset of R. Let us represent these sets through Venn diagrams. How do we represent a subset through a Venn diagram? Naturally, we represent the universal set in rectangular form. All the sets will be represented through a closed curve figures or generally in circles. Okay? Let us represent these sets through Venn diagrams. The number sets, these sets means natural numbers is a set, whole numbers. This is the one kind of representation of subsets. Let us represent the given number sets. Now, universal set is the numbers, natural numbers from 1 to 10. A is a set of 4, 6 and B is a set of 2, 4, 6, 8, 10. You see here. First you observe what are the elements are in A or in B. Then how do we represent? So, this is a mu universal set, that is A, 4, 6 elements were. You see. Now, the other elements are outside of B. So, this is the way to represent the subsets. Okay? Next, if A is not a subset of B, it is denoted as such A is not is a subset of B. Understand? For example, P is a set X such that X is an odd number less than 15. That means, odd numbers less than 15. C is a set C is equal to X such that X is a composite number less than 15. You know what do you mean by odd number and composite number. The given sets are in set builder form, we have to convert them into roster form. If you convert them into roster form, then P is equal set of 1, 3, 5, 7, 11, 13 less than, you are not supposed to take 15. C composite numbers starts from 4, 4, 6, 8, 9, 10, 12, 14. Okay? Then you observe here all the elements are in P 1, 3, 7, all are there in C? No. Hence, we can say therefore, P is not a subset of C. So, open your textbook and after completion of this concept, you can immediately do the problems in your textbook, and if any doubt you can consult your teacher. Again, we will consider the following set. Let us see, A is a set of players. I am taking the cricket players Sachin, Dravid, Kohli. B is a set of Dravid, Sachin, Dhoni. C is set of Kohli, Dravid, Sachin. You know, you might have known all the cricketers. Okay? Let us enjoy. Now, what do you observe in the above three sets A, B and C? Very simple. If you see the above sets, what do you observe? All the players that are A, Sachin, Dravid, Kohli, you see Sachin, Dravid, Kohli. The order is not important, but all are there. Also, all the players that are in C are in A. Understand? Again, thus A and C have same elements, but A and B are different. Understand? So that set A and C are called as equal sets. Now, we are going to learn about what? Equal sets. What is a equal set? Set A and C are said to be equal you see, if every element in A belongs to C, that is A is subset R equal to C. You see the symbol here, A is subset R equal to C, and every element in C belongs to A, that is C is subset R equal to A. That means A is subset R equal to C and C is subset R equal to A, then A is equal to C, then A and C are called as equal sets. Now, let us check whether the given sets are equal or not. See, A is a set P, Q, R, S and B is a set 1, 10, 100, 1000. A and B are not contain same elements, they are not equal sets. We can say A is not equal to B, they are not equal set, that is the notation. So, try this, you can try with your friends. I have discussed 3 problems. You see, P is a set of x such that x is a prime number less than 6, very simple prime number, and again Q is a prime factor of 30. You know, you have learned in prime factorization in your first chapter. So, let us think and discuss with your friends and whether check whether the given set P is a and Q are equal sets or not, discuss with your friends. Okay? Let them first, what you have to do? You have to convert them into roster form. After converting them into the roster form, what you have to see? You have to check the elements in P are in Q, or Q, all the elements in Q are in P. So, that is your check point. Please let us check. Let us see, think and discuss. How many elements are there in number sets, like you have come across earlier, natural numbers, whole numbers and integers. Let us observe the following sets. Can you list the number of elements in each set? Okay? In these 2 sets, we see that they contain finite number of elements. That means, we can count the number of elements. Such sets are called finite sets. Okay? Now, let us observe the set B and D. So, B is a x such x is a prime number and B is, you can convert into the 2, 3, 5, I am taking, and so on. D is a whole number, that is 0, 1, 2, 3. If it is possible to find out the last number in these sets, can you tell me what is the last prime number? Can you tell me the last number in the whole numbers? No. So, that in these 2 sets, it is not possible to find out last number or last element. Such sets are called infinite sets. Now, one more simple concept. Now, consider the following finite sets. Already you know, A is equal to set 1, 2, 3, 4, 5, 6. How many elements are there? Okay. Yes. Number of elements in set A is equal to 6. Now, what we have discussed? Null set or empty set, subset and universal set, finite sets and infinite set, equal sets, cardinality of sets. Okay? Dear student, try to solve the problems in exercise 2.3 and 2.4 of your textbook. Thank you very much.